Okay, so here's this experiment. They take 10 cars, they fill them up with gas, they run them around the track until they're out of gas, they measure how many miles they went. They do the same exact thing with the same 10 cars, and they put an additive in the gas and see if they do better. Okay, so that's a matched pairs test. Like before and after, it's the same car that's doing both of the treatments, not not two groups of 10 cars. So it's a matched pairs test. Now, and that would seem to make sense that you wouldn't want to use a different car because there's a lot of different things that could be different between two different cars. So, anyway, let's look at the answers. Which of the things is true? Well, A doesn't even really make sense. B, it is a so it's definitely a pairs test, so that's not right. The true mean of mileage is higher for cars without a, yeah, the difference is positive, right? This interval, so if they did, which they normally do, they do U1 minus U2, although they didn't state that, but that's normally what they do. If we got positive results, it would say that, yeah, they did better. It was actually pretty minimal, but it was better without the additive. Sample size too small. That's not that big of a deal. And then since the interval contains 0, we cannot. Well, the interval does not contain 0. It's not in there. So C. There you go. Okay, on this one, you got to be careful because they are talking about in hundreds of thousands of dollars. That's a lot of money. So the tricky part about this is that this is going to count as an outlier. So that means that right away we can cross this one off, and on letter E, they don't even account for this outlier at all. And then let's see, on B, this outlier is it's not even lined up. You see, it's not even lined up with the graph there. So C or D, and that's a question of whether you considered this an outlier or not, basically. So, and then let's see. But if you look at D, this back end doesn't line up with this graph there. So we are down to choice C. So sometimes you really can, just kind of with a little bit of information and thinking, and just calm down and just start to cross off the answers that don't make sense, you can get closer to the correct answer. Okay, let's go to the next one. Okay, so we have two ways of selling computers, I guess. So retail stores or manufacturer direct and web sales. So they don't really give you a key on this thing, but you can assume that this is a score of 92, and this is a score of 94. This is a score of 42. This is a score of 57. Don't forget, each one of those numbers represents 200 people, the average of 200 people who took a survey. So this store has a average for 200 people who took the survey. 66 was the average for those 200 people. Okay, let's take a look at the question. Which one is true? Okay, the ranges for the two ratings distributions are the same. Well, if you look at it, let's see, that's the high minus the low. So 94 minus 68 versus 82, which is the high, 42, which is low. If you subtract those, you get a number that is definitely different. Let's look at letter B. The rating distribution for the retail stores is skewed to the right. Well, let's take a look. If we turn this thing sideways, right, let's look at the distribution. So the retail stores is like this. So here's our lower numbers and our higher numbers. Don't forget, skewed is which one has the longer tail. So it's actually skewed to the left, not to the right. So B is out. Now let's take a look at the other ones. Let's see. like crossing these off, so those two are gone. The median of the rating distribution of the retail electronic stores is higher than the median of the rating for the distribution of the web sale stores. Okay, let's take a look. So let's look at the median. Let's see. So for the retail stores, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 numbers. So the middle number, okay, so 17. So I'm going to go 8 on each side. And so here we go. This one, 2, 3, 4, 5, 6, 7, 8. So it's right there. That's the median. So 73 versus the other one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll go 4. 1, 2, 3, 4. And it's somewhere between these two numbers, which would be an 84. So those are not the same. Cross it off. Here we go. We're getting closer to the right answer. So D talks about the IQR, right? The interquartile range. I don't want to figure that out right now. Let's take a look at letter E. The ratings for the retail stores are on average lower than the ratings on the direct sales. Let's see. Retail stores. Yes, look at this. You can look at right here versus this is higher. So I would go with E and not try to figure out D, because I think E is correct, and it is. There you go. Okay, I think this is kind of a tricky question because I feel like the question should say the hospital administrator wants to determine the 94% confidence interval for the mean number of days that the patient stay in the previous year, right? It doesn't say that. It just says stays at the hospital, not for the previous year. Now, and the reason I say that is that seems unfair because the answer is A. Confidence interval cannot be constructed when the population data is known. So what they're saying is the data given to her by the hospital business manager will list the length of stay for each patient for the previous calendar year. So basically, they have all of the data. There's no point in doing a confidence interval if you want to do it for the previous year, but they don't really say that in the beginning of the question. So I think that's a little bit unfair, but the answer is A. Okay, let's do the next one. Okay, this question kind of freaked me out a little bit because as I read, let's see, the distribution of ages of females in the United States is strongly skewed to the left with a mean of 82 years. So the average age of women in the United States is 82 years old. Kind of flipped out about that. Let's see. Strongly skewed to the left. So it's got a long left tail like this. So maybe the middle is right here at 80. I don't know. Okay, I'm just going to keep going. So a random sample of 20 females is taken from this population, and the mean age of the sample is calculated. This is repeated 500 times. Which of the following describes the shape of the sampling distribution? Okay, so that's like if we did that and we made a dot plot, right, for each one of these 500 times that we took a sample of 20 people. Now, if you remember, unbiased estimator, so the mean is going to be 80.2. Okay. Let's see, what else? So I'm going to go with, nope, that's wrong. A is out. The mean, no, that would be the standard deviation. Let's see. What do we got? Skewed to the left with a mean of 80.2. Yeah, the sampling distribution is going to mirror your population, so I think C is the answer. Let's look at D. Approximately normal distributed with a mean of 80.2. No, it's going to be skewed, so that's out. And then approximately normally distributed with a mean, the mean of 80, no, that's wrong. Okay, so you might have come down to C or D, but the answer is C. There we go. And Wango.